for the final presentation for this morning, we will be looking at regional scale modeling of land use, and the title of the presentation is OSMlanduse, a dataset of European Union land use at 10-meter resolution derived from OpenStreetMap and Sentinel-2. This will be presented to us by Michael Schultz, and this was written with his colleagues. This is a pioneering work that focuses on fusing OSM's semantic richness with Sentinel-2's spatial detail, and is said to be the first EU-wide 10-meter land use mapping using a fully open workflow.
Hello everyone, I'm presenting today the OSMlanduse, a dataset of European Union land use at 10-meter resolution derived from OpenStreetMap and Sentinel-2. I'm Michael Schultz and I'm from Tübingen University, although this work was performed at Heidelberg University. So let's dive right into it. Here you find the access to this product. We have a web representation hosted at Higit. We have the respective paper as a scientific dataset paper and a link where you can download the data itself. So this is how it looks like. On the top of that, you can essentially see the article link if you want to jump right into it. And the abstract says it very nicely. Our map is the first successful large area fusion of OpenStreetMap and Copernicus data at spatial resolution of 10-meter or finer and can be applied globally. So we did this application for Europe. However, there are no limitations for whatsoever where you want to go. Right. So this is how it looks like. This is an area in Germany, Bochum actually, and it's a bit wild. So when you zoom in, so some of those areas are rather pixelated. These are spots that are predicted using machine learning and Sentinel-2 feature space. And those areas which are looking a bit more smooth, it's much more easier for you to identify when you go online to osmlanduse.org. They are directly derived from OpenStreetMap. Essentially, it's a translation of key value pairs and tags into certain land cover categories. Method is pretty straightforward. So left-hand side, you see we have OpenStreetMap, and we extract objects using their tags, key value pairs, and then we have essentially labeled land use. This in itself is already a map. It's an incomplete map with white spots, as you can see from this example on the top right-hand side. So some areas are colors. Those are those areas which we could relate to land cover classes. And then we have those areas that are white, where there is no information on respective land use and land cover classes provided by OpenStreetMap. So we fill those gaps. And this is how it goes. So then we have this Sentinel-2 feature space, 10-meter resolution, and we pre-process it. And then we use the already existing labeled land use and inject it into a classification model. And use Sentinel-2 as feature space, use the labeled land use that is existing in OpenStreetMap as training data, use a classification model, perform the classification, and then we essentially have a gap-filled or conterminous land use map. All right. So there's OpenStreetMap, Bing here, different providers, can be applied at different places. The extraction process is pretty straightforward. We have used the OSM API, and we can filter by area of interest, time range, and so on. So this product, in theory, you can apply it to various moments in time, and you can also modify it for different themes and different thematic arenas, not just like land use. Maybe you just want to narrow it down to something maybe only phenological applications, maybe only urban applications, and so forth. Here we just demonstrate the capability of OpenStreetMap to put this land use, land cover lens on top of it. Right, these are the key value pairs that we have used. Left-hand side is actually the target class that we have used. It's the CORINE Land cover classes, and then we identified from previous work the corresponding OSM tags of the the object, and then we just take the composition of those objects, and all of them then form the specific land cover class. Right, this is how it looks for different sites. Yeah, this is essentially non-gap filled, just like this table, essentially, just this table applied, but not gap filled. The left-hand side is Fresno, and then Israel, and then I think this is Hong Kong on the right-hand side. And then once we essentially we pull all these things together, and then we perform the classification, right, and fill the gaps. This is how it looks like. Here we are different facets and examples of how this product looks at the end of the day. Works good in most of the places. This is different availability of training data. So this graph shows you to what extent areas are already 100% covered, or to what percentage they are covered by the training data. The performances, some classes work well, some don't. I recommend you look at the paper. I hope this teaser was interesting for you. And yeah, thank you so much, and have a lot of fun at the conference.
Right, so we thank our three presenters for the first lightning talk for today for the academic track.